Hi, everybody. Welcome to the SIG Testing weekly meeting. Today is Tuesday, June 30th. This meeting is being recorded and will be posted to YouTube later, so please be on your best behavior and adhere to the Kubernetes code of conduct by not being a jerk. On today's meeting agenda, we're going to have Michael Colbert walk us through his proposal to port triage and any free discussion items we have after that. So, Michael, I will hand it over to you.
Sure.
I probably need to give you permission to screen share. Let me do that. Okay, there you go. You should be good to go.
Okay. Okay.
Yeah, I can see.
So this is my design proposal for porting triage from Python to Go. In short, for anyone who's not aware, what triage does is it takes a bunch of messages, failure messages from failed tests, and aggregates them. So for instance, you have a bunch of tests that run, and then some of those tests will fail. And then when they fail, they emit error messages. So we take these error messages, we compare them based on edit distance to see how similar they are, and then we group them by similarity. And then the largest groups appear at the top, going down. So this is what it looks like once they've been aggregated. And so you'll see you have just a skeleton of a failure message, and like all the messages in this group look similar to this. And then you have a list of all the times it failed and a frequency graph, a bunch of great things for analyzing all these messages that we get. And it just allows developers to know where to focus their efforts.
Michael,
The
do you
reason
mind zooming in a little bit? It's kind of tough for us to read the text right now.
Sorry about that.
All good.
How's that? Okay, I hope that's better.
All right.
Right. The primary reason for porting from Python to Go is that most of the Kubernetes infrastructure is written in Go, and so having more of the infrastructure written in Go will allow easier interaction between different tools and allow the developers who are already on the project to more easily work with it. In addition, we're hoping that this will improve performance. If solely porting to Go does not itself improve performance, then we will take additional steps to improve the performance. Okay, triage is composed of a few components. You have the main summarizer. You have a edit distance formula, and then you have a shell script that basically organizes everything. And it just takes data from BigQuery, analyzes it, and uploads the results into Google Cloud Storage, where it can then be analyzed using this website over here. There are roughly 1,500 lines of code to port, a third of it are tests. Some of it is heavily math-based, so it shouldn't be too difficult, and the rest is Python specific, and so that requires a little bit more effort in terms of porting. Because it's meant to be a drop-in replacement, only minor changes will need to be made to the surrounding infrastructure. There shouldn't be too many changes to make. If this is done right, we just have to change the line that says call Python to call Go. And the entire thing runs on Google Kubernetes Engine. Right now, it's taking around 25 minutes total per job. We hope to reduce this. In terms of testing the compatibility of the Go port versus the Python port, there are a few ways we're going to do this. We're going to test the output to determine if the outputs are similar. Because of some non-deterministic factors in the way that the program runs, it's not easy to produce the exact same output for both of the versions, for the Python version and for the Go version. And so instead, what we're going to do is we're going to compare the percentage of similarity in the clusters or the groupings. So let's say the top cluster from Python and the top cluster from Go share 90% or some other percentage of their texts, their failure messages, then we'll consider them to be the same. In addition, some of the functions are memoized to JSON files. And so if that's being done, then what we can do is we can run the Python and then try to load those memoized files into Go, or vice versa. Run it in Go and try to load those memoized files into Python and make sure that they work with each other. In terms of integration, because it's a drop-in replacement, we don't expect for there to be too many issues in terms of the surrounding pipeline. Data, as you can see in this diagram, really only flows one way, and it ends with triage. So there are very few downstream consequences to worry about. Any compatibility issues would originate within the actual port itself. In terms of ensuring that it works within the context of the pipeline, what we'll be doing is we'll be setting up two different instances. We'll be keeping the existing Python instance, and we'll also be setting up a Go instance. And so we'll be able to have them run side by side, triggered by the same events. And that way we can actually get a real-time comparison of how they're doing in regards to each other, and we can flip back and forth between them and say, oh, this one's doing better in this way, this one's doing better in that way. In terms of correctness, there's no real correct result here. This is a very subjective metric. It's really meant for human consumption, and so a lot of the correctness is going to have to be, to a certain extent, approved manually. In terms of migration, we'll be updating the Kubernetes engine image that the Proud job uses, so that it has the necessary Go runtime, but that's going to be farther down the line when we're actually converting this over. In terms of efficiency, and that's, again, one of the latter steps, one of the ways that we could do this is multi-threading the classification. So right now, you have, in the first stage, you have, for each test, all the error messages for that test is grouped into groups. And so because each test is fully independent of every other test, then what we can do is we can run each one in parallel without having to worry about any overlap between them. In the second step, the groups from the previous step are mixed and matched together, but it still should be possible to multi-thread that as well. And because Go has Go routines, it lends itself to this quite well. And in addition, since triage is always using a rolling window of the past 2 weeks data, and previous data never gets updated or changed, what we can do is we might be able to run an incremental analysis. Since we're every time we do another analysis, we're taking off the same amount of time from the beginning of the analysis. What we can do is we can just keep that chunk in the middle that we analyzed already, and then maybe just add on a new piece of data. And this could cut down the running time to a fraction of the time before. And just to go over some alternatives considered, could have left it as it is, but we see job times are steadily increasing. Occasionally they increase to over an hour, and we don't really have anything that points to a specific issue that would be causing this. So that's out of the question. Optimizing the Python code was another option, but it's pretty optimized as it is. It uses a pretty fast Python interpreter, but we just don't think that any Python implementation can keep up with a compiled version. The maintainability and compatibility with the Kubernetes environment is a larger priority, and part of that involves writing it in Go. And lastly was transpile the code and then fix it up. So transpile it from Python to Go and then work on that Go code. The problem is that there are no good Python to Go transpilers, and certainly none from Python 3, which is what Triage is written in. And yeah, that's about it.
Cool. Is there any concurrency in the current Go implementation?
The Python implementation?
Yeah.
No, there is no concurrency right now.
When you said that you'd have the Go and Python side by side that you could flip flop between, do you mean we'd actually have both instances of triage running in parallel on the same data to juxtapose the output?
Yeah.
Okay, cool.
Yeah, for what it's worth, I just took a look at the runtime for triage, and it's been slowly creeping back up to like from 20 minutes to 40 minutes with peaks up at 80 or 90. And something I took a look into a little while ago, and it was just kind of not clear that anything in particular had changed to cause triage to balloon its execution time all the way up. And then it mysteriously kind of went back down. So I feel like that's part of why I am very hopeful that the gains we get from rewriting this in Go and potential optimizations we use will help us out a bunch, because I personally find the triage tool to be really useful for tracking down failures.
My like most used tool for that by far.
Yeah. Any other questions for Michael? Okay. Thanks for presenting that, Michael. Really appreciate it.
Sure.
So I saw somebody added something to open discussion on how to best advertise and make public coverage and other test metrics. Does anybody want to speak to that? Okay.
Yeah, I'm about there with adding at least the coverage metrics for the CI Kubernetes coverage unit tests that run in Prow and are in test grid right now. But getting to those actual coverage metrics hasn't been easy. I'm almost there for adding them as short text in text grid, which gives you the option to like actually have the graph of them over the test grid runs. And I was going to add the link at least to that within somewhere in the Kubernetes test infra. But I was just curious for those of you guys more ingrained in the SIG, how you think people are actually going to use those numbers and where they should be advertised so people can use those numbers.
And currently they're in SIG testing canaries. I think they need to move out of that.
Yes.
One idea might be attempting to figure out which packages are owned by various SIGs and giving them filtered dashboards of like how their code is doing. Like in each SIG dashboard, test grid will let you display results, but with a like regex filtering out which test names. I think that might be a workable approach. Otherwise, my go-to is usually SIG release for getting a team looking at something overall, but I don't think that applies here. Maybe architecture, the code cleanup sub-project. I'm not sure. Or even just like a SIG testing dashboard that is suggestive of being serious versus canaries would probably be an improvement.
Got it. Yeah, I mean, there are a whole lot of tests in this dashboard.
I think the community
right now
also still has like open for demos. This might be something worth trying to like show to the broader project. Like, hey, we have this now. You can, look at it for improving.
Yeah, this canaries dashboard, you'd scroll for, probably an hour if you want to just look through all the cells and all the tests that are run for coverage. So it probably would be good to filter out into something a little bit more digestible per per interest group.
So a couple thoughts I have. One, I'd be interested to understand. I feel like the place to put it where you're going to get the most eyeballs is on people's pull requests. But I suspect that since we're talking about a CI job, I'm imagining that this takes a really long time to run. So it may not be at the place where we're able to run it for every pull request against Kubernetes right now. It would be interesting to figure out how we could go from sort of an informational view of, hey, here is all the code coverage, to a more actionable, like, hey, code coverage is going in the wrong direction because of your pull request. I'm not entirely sure how to get to there from where we're at with the CI job, but that's one thought. Another thought, I don't know that we use this on the Kubernetes instance of test grid. So I would check to see if this is supported, but I know test grid supports the idea of like hierarchical results. So instead of displaying however many thousands of rows there are on this dashboard, it could like roll everything up to a package level, and then you could click to drill down and see like sub packages or the different tests or things of that nature. That feels like maybe a useful way of summarizing the data a little bit. And
you can roll them into test suites and then have those test suites drop down into the individual test cases. Okay. I'm not sure right now how to enforce what a test suite is, but I'm sure it's doable.
I see.
It's being generated right now. The XML is being generated off of the coverage file, which is pretty much a flat .cov, and Gopherage generates the XML from that and creates flat test cases. So everything is flat right now. It might just be a Gopherage tweak that allows us to bin them in certain hierarchical levels. And it looks like the job takes about 30 minutes just based off the job history that I'm looking at, or somewhere between 30 minutes and 2 hours.
The hierarchy right now is defined by GoTest, but we could make something that rewrote knowing which package was tested and making that into a JUnit hierarchy. I think test grid can actually display that, which might be helpful.
Sorry, could you say that part again, Ben?
The hierarchy as it stands is just based on like as GoTest understands it, but there isn't any reason we couldn't rewrite that after the fact.
Yeah. So I'm just looking at like some of the coverage stuff that we have talked about in the past has come from Knative, and so like I linked their coverage view in chat where it looks like they only have one level of nesting. And I guess, Grant, you're saying that so each row here, like, so test grid is parsing a row for each test suite in the JUnit XML, and then each sort of drop down from that is a test case.
Yeah, so this is what it looks like for the Canary coverage, and then you're correct, the Knative stuff has that singular drop down for different bins at the test level or package level.
Okay.
I don't know if you can get more broken up than that. I don't know if we could do it for every level of the path, but maybe. I'm not that familiar with test grid to know. But at very minimum, I think we could at least duplicate break everything into multiple test suites, and within a test suite have different test cases based on some package hierarchy.
Okay. Yeah, I feel like that would be useful because so yeah, I guess looking at the SIG testing canaries thing, I don't even entirely understand what I'm looking at here, since it's got a row for each test, and what I would expect of you for coverage would be more like what Knative has, which is showing me a row for every single file that would be in the repo, and then the coverage on that file. So yeah, I feel like there's more processing of the JUnit XML, or the conversion from coverage to JUnit XML, that needs to happen.
I think it might be a little bit more manageable if it's per package. You can drill down into the file information if you click through the artifacts, but I think on test grid, if we try to have a row per file in Kubernetes, that's gonna be a tad out of hand.
Yeah, it very well may be. I would anticipate we probably don't want to like show it for vendor, right? But we may want to show it. So I guess an open question would be: we probably don't want to show it for vendor. Do we want to show it for everything in staging? I probably would want to show coverage for everything in staging, but that might be an example of different views for different people. Like some people focus only on certain subdirectories inside of Kubernetes. So yeah, I'm surprised it's taking 30 minutes. I thought it took a lot longer than that for some reason. 30 minutes is really not bad at all.
That was one of the shorter ones. Here's the prowl link with the history. But it looks like anywhere from 30 minutes to 2 hours.
Okay. Well, that's taking its sweet time to load. So I don't know. I feel like we've had certain voices contributing a lot. Do any other people have opinions or suggestions on how we could make code coverage presentable and usable for everybody? Okay. Well, yeah, that's true. We do have this wonderful spyglass view, which is an amazing tree map, but it's not like I kind of have to hover around the tree map to see what's what. Share.
Extending that may be a useful way to attack this problem.
Yeah. So this thing, like if I hover over it, it does actually tell me what each of these squares corresponds to, but I can't like click it to go to that file or anything. And I can't necessarily see like sort of a tree map, or sorry, like a tree sort of structure where I could like see the different directories and files and stuff. Something I would see from like codecov.io or whatever. So that's the sort of thing that Knative's version of test coverage could give us a little bit. I also, like one thing that seems nice here is I guess they have a threshold they're choosing for what level of code coverage is acceptable or not, which probably would be helpful for us in terms of making this actionable. I guess we have to kind of know how bad the coverage is right now. And this doesn't necessarily tell me how good or bad our coverage is individually. And Zoom's thing is in front of my tabs, so. Ballpark 60% for the project. That's better than I thought it was. But I think in terms of, Ben had mentioned something about putting it on a release dashboard. I could see this maybe finding its way onto the release informing dashboard. Like if we get it to a place where we know what level of code coverage we feel is acceptable and everything is green when we're meeting that. And then if things start to go red, if the coverage drops, that's the sort of thing where we could get help from the CI signal team in monitoring that and deciding whether or not to act upon that. I still think that sort of thing would ultimately be great to have as a pre-submit job that's run against every pull request. And if it truly only takes like 30 minutes to do this, that might be worth looking into as well. So I don't know. Those are just my thoughts off the top of my head.
All right, well, thank you. I think I got a lot of stuff to go off of, so I can at least have some direction for it.
Okay. Does anybody have anything else they'd like to talk about, or 30 minutes back? All right. Thank you, everybody, for your time. It was great to see you, and look forward to seeing you all in 2 weeks. Until then, happy Tuesday.
Happy Tuesday, everyone.